Hello, good day everyone, and welcome to this week's Inventor feature session. You are here with Yashin from Modena OneSolve, and the feature that I'm going to be showcasing how to work with today is the Coil Command. The Coil Command is a brilliant tool. It essentially combines two features into one operation. That will be the sweep and the creation of a helical curve, and it's a fantastic tool to use for creating thread profiles or cutouts for drill bits, screws, or even something like a feed screw. So there are a couple elements that you'll need before you actually run the coil, and that will be a solid body or feature such as a stub, um, a work axis. The work axis is going to define the direction of the coil. This can be a sketched entity too. Over and above that, you'll need a closed profile or a pitch profile. Okay, so thread profile, pardon. So how this works is I've got a thread profile that's already been created directly in the middle of my model. So I'm just going to activate it so you can have a look at where it is. Now I cannot actually see my thread profile that I've created at this stage. I'm going to quickly hit F7 on my keyboard to temporarily section the view, and you can see there is the thread profile or closed loop that's been created. Okay, so now that we have all our elements in place to create the coil, all I have to do is toggle on the command from the ribbon, and that will open up the coil dialog box. Inside this dialog box, the first selection that will have to be made is the profile. So if I zoom into my sketch, it's automatically been selected because it's the only closed profile available at this stage. Next step is defining the direction of your coil. This is done by choosing an axis. So I can simply toggle on the axis button and head over to my model and choose that work axis. And you'll notice a preview of the coil appear. The next step in using this feature is actually defining the direction of the coil. Okay, so like I said, the axis has defined the direction. We can also flip it around, okay, if it doesn't go the right way. However, initially it was going in accordance to the direction of my model, so that's a-okay. The next step is defining the behavior, which is going to be the size of the coil itself. The methods you do have a few options depending on the thread criteria that you have. So you have things like pitch and revolution, revolution and height, as well as pitch and height. So those will control the size of the helical coil that's being created. The pitch will be the distance between each coil rung. The number of revolutions will be the amount of turns, and height essentially will define the length of the helical curve. In this case, what I'm going to use is pitch and revolution. My pitch I'll set to a distance of 4, and the revolutions I'll keep at 12. And as I increase this, you'll notice the amount of revolutions will adjust on the helical curve. So I'm just going to keep that back at 12. Over and above that, just below the revolution and taper, you have this rotation button, so you can define whether it's going to be left hand or right hander. So there's going to be a left thread or right handed thread. You can make those specifications there. Last but not least is the output. Okay, what are you trying to do? Add material or remove? So your Boolean options are going to be exactly the same as what you would find in extrude. In this case, I want to remove material, so I'm going to turn on the cut option and simply select OK. And there you have it. You have a thread profile that's been created very quickly inside of Inventor. Thank you for joining me in this session. Stay tuned to our channel for more content.